Okay, got another step response of an RC circuit. This one's not too hard. It's kind of a review of the process, and then they throw in a little thing at the end. So there's a switch here that flips at t equals 0 and connects it to the other side while the switch is in the first position. It's connected to a 0.02 microfarad cap. This is the voltage across the cap. There's a 40 kilo ohm resistor here. There's a 1.5 milliamp current source. There's a 10 kilo ohm, a 3 kilo ohm, a 9 kilo ohm. Yeah, and we're asked to find a series of things. We're asked to find V sub C at 0 minus, so the initial voltage in the cap before the switch is thrown. Then the voltage in the cap at positive infinity, which is the final voltage, and then tau. Basically, with these three here, they're walking you through the general solution for V sub t. I'm sorry, V sub c as a function of time. And so they're walking you through the general solution for the voltage in the cap as a function of time. Then the last little part is a little trick. They're asking what is t? What is t for V sub c of t equal to 0? Basically, they're asking you when does V sub c of t equal to 0? When. So this sort of implies that the V sub c signal may cross the x-axis, and in fact it will. In fact, it's going to do something like, it's going to do this. And they want you to solve for this time right here. So once again, the way that we do these things is we solve the circuit at minus infinity, 0, and positive infinity. So at minus infinity, redraw the circuit. The cap, in this case, V sub c at minus infinity, it acts like an open circuit. It's still there, but it acts like an open circuit, so voltage division is a solution to part A. Voltage division, basically V sub c at 0 minus is going to be 120 split by 9 over 9 plus 3. It's going to be 90 volts. That's our first answer for part A. Part B, what is tau? No, that's part C. Part B is what is V sub c at positive infinity. So draw the circuit at that condition. I'm kind of lining it up with the top circuit here. Could label these. This is A, this is B down here. So this is before the circuit was, before the switch was flipped. So call this C really. The cap was connected in here, and then when the switch is flipped, now it's connected here. So there's a cap in here. So this is VC at positive infinity. And it's going to have some, well, we need to keep the same reference polarity plus at the top, even though this current right here is going to, you know, make a polarity or a voltage in the opposite direction. So we need to throw in a minus sign here. So V sub C at positive infinity is, throw in a negative sign. It's going to be 40 times 1.5, and this is just V equals IR at this loop right here. See, so this guy here isn't really well, it's here, but it has no effect because there's no current in this little piece of thing just hanging by one node. It's not a circle here, it's just a pokey out thing. So this is minus 60 volts. That's part B. Okay, tau. They want us to find tau, so we need R equivalent to find that. So we draw the, use the open eyes and the short V's. This is opening the eye, making it an open circuit, and you're looking for, you know, R equivalent seen by the cap. So that's across terminals A, B. What does the capacitor see as the resistance? So it sees it's just 10 plus 40. The cap sees 50 kilo ohms. So then tau is RC. So it's 50 kilo ohms times 0.02 microfarad. It's going to be 1 millisecond. That's our other answer. So our general solution for these kinds of step response problems is x of t equals x of f plus x sub 0 minus x sub f e to the minus t by tau. And for a cap, you know, x is voltage for in this general solution. So V of t for the cap is, it had a final voltage of minus 60 plus an initial voltage of 90 plus 60 e to the minus 1000 t. And cleaning that up, it's minus 60 plus 150, minus 1000 t. So this is VC of t, which they're not really asking for, but we need it. Well, they're asking for when is this 0. So this thing is, so VC as a function of t, it 150 minus 60 is going to be 90. And then it's going to decay down to minus 60. So it goes like that. And this is a cap. It's not going to have a step, so it'll be continuous before that. So we want to know what is this t value? When does it cross the x-axis? So we want to know when is VC of t equals 0. So set it equals 0. It's VC sub t is minus 60 plus 150 e to the minus 1000 t, set to 0. So then just to go over the algebra, because it's a little bit weird, a little bit unusual, but it's 60, moving that to the other side. And then you can move this minus 1000 t to the denominator and just change the sign. That's one of the rules of exponents. Then you can move that over there, move this to the left and the 60 to the bottom, so you get e to the 1000 t equals 150 over 60, and then you could take the natural log of both sides. So you know, ln of e to the 1000 t equals ln of 150 over 60, and ln of e to the minus 1000 t is just 1000 t equals ln of 150 over 60. So t is ln of 150 over 60 over 1000. Punch your buttons on your calculator and you get 916 microseconds. Nice little problem.